Hello, today we're looking at circles and the equations of circles, the algebra to do with them, all of that stuff, and let's launch straight into it. I'm not going to bother drawing a circle because you already know what a circle looks like probably, and also nobody wants to go through the pain of watching me try to draw even a half decent circle if I don't need to. There'll be plenty of time to laugh at my circle drawing abilities in some of the other future videos on this topic, but for now, what is the equation of a circle? It's actually quite a simple idea. All you got to do is have an x, take away a, in brackets all squared, plus y, take away b, in brackets all squared as well, and then that's equal to r squared. A, b, and r are just placeholder letters to represent things that would normally be numbers that then define certain aspects of the circle. For instance, the center of the circle, which is just going to be the coordinates a, b. The x coordinate of the center is a, the y coordinate of the center is b. Do note, therefore, though, it is a minus a and a minus b inside the equation of the circle, but then it's positive a, positive b for the coordinates. In other words, what you see inside the equation is minus 1, lots of what's happening in the coordinates. And then also, you can know the radius of the circle from the equation of the circle because it's then just the value of r. Cool. So really that's all there is to it. You have to remember this structure off by heart and then be able to use it. For instance, we could have a couple of very simple examples. For instance, what is the equation of a circle with a center of 3 minus 7 and a radius of 4? Well, straight away we can just jump to writing the equation because it's going to be x take away 3, so a coordinate of positive 3 for the x, but then remember it's minus 1 what you see in the coordinates that's appearing inside the equation of the circle. And then also for the y, it's a y coordinate of minus 7. Now you could write minus 7, but minus 7 of course is then positive 7. So it's y plus 7 squared, and then that's going to equal the radius squared, so that's 4 squared, and 4 squared is 16. So that is therefore the equation of a circle with a radius of 4 and a center with coordinates of 3, minus 7. Brilliant. Question 2, same idea in reverse. We've been given the equation this time, and now we have to identify what is the coordinates of the center and what is the length of the radius. Super easy to do. We can see that it's got a plus 2 here, therefore that would be a negative 2 inside the coordinates for the x coordinate because it's the number next to the x, and then the number next to the y is minus 4, and remember again it's minus 1, lots of what you see in the equation, so minus 1 times minus 4 is positive 4, so the coordinates of the center is minus 2, 4, there you go, done. Length of the radius, well, we got to realize the number on the end is not the radius, it's the value of the radius squared. So if we want to find the radius, we got to square root that number on the end. Obviously though, a reminder, do put things in surd form. You should naturally do that anyway. And the good news is your calculator will often do that for you, so it's not even you need to put any effort in, just whack it in the calculator. But this is one you should be able to do manually anyway as well. But either way, you should get an answer of 2 root 6 as the radius. So there you go, that's the center, that's the radius. However, there is one little extra thing I want to point out, and that is we can only read off the center and the radius if the equation of the circle is in the format we'd seen before very, very specifically. We could get a question like the one you can see on the screen right now, and the problem with this equation is it's not in the format that we've been dealing with. It's not in the format, in brackets, x minus a all squared, and it doesn't have the y minus b all squared, and then we don't have the number on the other side, which would then tell us what the radius is. So, therefore, we can't read that information off. In fact, I was going so far as to point out that some students make the mistake of just going, well, surely we can just move the 1 over to the other side, and then there you go, that's the radius, the square root of 1. But, A, you would notice straight away that if we do that, we'd end up with a negative number, which we can't square root if we're sticking to real numbers. And also, even then, that wouldn't give you the value of the radius because it's only the value of the radius if it also has the squared stuff on the in brackets on the left hand side, which it doesn't yet. So what you've got to do in order to be able to read off the center and the radius is you need to then put the equation back in that form that you want it to be in. Because that's the only time we'll then be able to do what we were doing before. So the way you do this is completing the square. Yes, it's coming back. See, that's the thing. A lot of some students sometimes go, oh, I don't need to learn completing the square because there's other ways of solving a quadratic other than using completing the square. There's other ways of finding the minimum point of a quadratic other than using completing the square, even though it can do both those things. But you still need to know completing the square because it also has other uses, and this is one of those uses. So, the weird thing about it though is we've got more than one letter with squareds involved here. We've got the x's, and then we've also got the y's. And what that means you've got to do is you effectively got to do completing the square twice. Once with the x's, and then once separately with the y's. It's worth pointing out when doing this, this is one of those moments where it really is a good idea if you are one of those people who just does the following when you complete the square, which is to look at the number that's in front of the power of 1 term and halve that and put it inside some brackets with the letter all squared, and then just automatically get used to then subtracting whatever number was appearing inside the brackets squared. Rather than doing that method that some students like to do where they like to try and multiply out the brackets and see what you've got and then adjust the number that's on the end based on what number you currently have. And the reason that method is, although it works, is less preferable here is because you're going to have to do it twice. It's going to take you longer, as well as the fact that because we've got lots of different numbers going on, it can be very easy to make a silly mistake with that method here. So we then repeat the same with the y's. So we see the number that's in front of the power of 1 term for y, which is -3. And even though that's not a nice number, we still just halve it. Whatever it is, halve it, put it inside some brackets squared, and then take away that number all squared. Whatever it is. And then the thing to be aware of is to remind you, we're just completing the square with just the bits that got the x in, and then completing the square with just the bits that have the y in, and that means we've done nothing with the +1 so far. And so if we've done nothing with it, it's still got to be there. So don't forget to put that number on the end. The rest of the question is then just simplifying it after that. We've of course got the x plus 5 all squared. We've got the plus y minus 3 over 2 all squared. And then ultimately this is where you could use the calculator as long as you make sure you use the brackets like I have done around the minus 3 over 2. Over here, but therefore you could type that all in. I don't have a calculator, stupidly. I don't know where mine is. Let's do it. We're going to do it manually. So that's minus 25 minus 9 over 4, which would be minus 109 over 4 plus 1, which would be minus 105 over 4, I hope. Of course, what you want to do after that, though, is just finish off actually properly writing it in the format of the equation of the circle that we've been dealing with already, which is having the number by itself on the other side. Because once we've done that, we can now find the center instantly just by reading it off. So the center, of course, is minus 5 and positive 3 over 2. Doesn't matter, there's horrible numbers. Whatever numbers you're seeing inside the brackets with the squareds, give the coordinates of the center. And then the radius, again, not very nice number, but it doesn't matter. All you've got to do is just work with that, and by that I mean realize that this value of 105 over 4 is the value of the radius squared, so you've got to square root that. So the radius is therefore equal to the square root of 105 over 4, but again, put it in third form. I believe that if you put that in third form, it's root 105 over 2. And there you go. That's how to do that. You can use completing the square to rewrite a circle equation so that you can read off the center and the radius. Future Greg here. I thought I'd add a little extra bit onto the end of the video because some of you might be wondering, why does the equation of a circle have the form that it does? You don't really need to know this for the exams. That's why I didn't include it earlier in the video. But for those of you who are curious and just like to know this sort of stuff because it helps you understand what's going on a bit better, I thought I'd add it in anyway as a little extra bonus thing. Ultimately, if you have a circle with the center of A, B as coordinates, and you've got a point on the outside, let's say it's going to have the coordinates x, y as general coordinates for any point on the outside, then we can form, between these two coordinates, we can form a right angled triangle, because you know the direct straight line distance between these two things would be the radius. But then we can also form the right angled triangle by doing this. Then, if you want to know what the other side of this right angled triangle would be, it's about looking at the individual coordinates. For instance, the base of this right angled triangle would be the x coordinate of the point on the outside of the circle, x, take away the x coordinate of the center of the circle, a. So therefore it's x minus a as the length of that base of the triangle. And the length of the height of the triangle, well, that'll be y, take away b. And if you use Pythagoras, and if you do Pythagoras with these things, you will therefore end up with x minus a all squared plus y minus b all squared is equal to the hypotenuse squared, which should therefore be r squared. And there you go. Ta-da! That is the equation of a circle. Okay, that isn't where it ends for circles. We do have some future things to look at in some other videos. So hopefully I'll see you in those videos. Hope you found today's stuff useful. Goodbye.